Similarly, we can calculate for 10% modulus of Zn. For the two-tail, it is 1.645 and Zn is 1 point, this we already did. Zn is 1.28 and the minus 1.28. Similar calculation we can do it, what we did in the previous. Okay, now we'll go to the next. We'll solve the sum now. The first question is, example 1. We'll see this question, example 1. Okay, a machine, this one. This question I'm talking about. Can you see this question? I think it's clear, no? Okay, this question. Okay, now it is clear. Okay, a machine produces a component of a product with a standard deviation. With a standard deviation 1.6 centimeter. A machine produces component of a product with a standard deviation 1.6 in centimeter in length. A random sample of 64 components was selected from the output, and this sample has mean. Sample mean is 90 centimeter. The customer will reject. The customer will reject the part if it is either less than 88 centimeter or more than 92 centimeter. Thus, 95% confidence interval for the true mean length of all components produced ensure acceptance by the customer. That is a question. So, what are the data given? We have to see. First of all, it is a machine, right? It produces component of a product with a standard deviation. So, this is population standard deviation 1.6 centimeter length. A random sample from that 64 components are taken, selected randomly. The sample was selected, output, and this sample has mean length. Sample's mean length is 90 centimeter. Whether the and then one more data is given. If it is less than 88 centimeter or more than 92 centimeter, the customer will reject. Okay, the component will be rejected by the customer. Okay, so now the question is, does 95% confidence interval does 95% confidence interval for the true mean length of all the components produced ensure acceptance by the customer? So we'll try to solve this sum. What are the data given? We'll write it down. What is sigma? Question 1. Okay. In the question 1, what is sigma given? Sigma is 1.6, right? Sigma is 1.6 and Z alpha by 2. It is 95%. No need to see again table. We know Z alpha by 2 is 1.96. By this time you should have memorized it. X bar, the population mean is 90. Sample size of the sample n equal to 64. These are the things given to us. Okay, sigma equal to 1.6 and so SC standard error is sigma by root n and sigma is 1.6 by root n root 64 that is 0.2. Then we use the formula and we'll check it. Okay, question 1, what is given? Sigma. Sigma is 1.6. Okay, and Z alpha by 2 is 1.96. Okay, X bar equal to 90. These are all given in the question. Okay, sigma is 1.6, so Z alpha by 2 is 1.96. This is from the table. X bar is 90. It's given in the question. The size of the sample is 64. Okay, standard error using the formula is sigma by root n What is sigma? 1.6 by root n. N is what? 64. So 1.6 by 8, 8 is 64. 8. So 0.2. This is the standard error, right? What is the formula? Formula is alpha. We write the formula. X bar. The probability will be x bar minus z alpha by 2 sigma by root n lesser than or equal to mu less than or equal to x bar plus z alpha by 2 sigma by root n. Okay, x bar is what? X bar is 90. Okay, substitute here minus z alpha by 2 is what? 1.96 into what is sigma? Sigma by root n. We have calculated now 0.2 standard error. So we can use that. Less than or equal to mu less than or equal to 90 plus 1.96 into 0.2, right? So what you will get? The some centimeters will get, right? That is 89.61 less than or equal to mu less than or equal to 90.39. Okay, so you will be getting 89.61. The interval lesser than or equal to is given now. So closed interval 90.39. Okay, 90.39. Okay, this is my confidence interval. So this implies that probability that the true value of the population mean length of the component will fall. So population mean length will fall in this interval. Which interval? 89.61. And to what population? This is what is the population mean? Mean will fall in this interval. Okay, population mean. What is the population mean? Population mean length of the components. Population mean length of the components. This is what percent you are sure? 95%. Confidence interval is what? 95%. Therefore, hence we conclude that 95% confidence interval ensures acceptance of the component by the customer. So what is the question given here is 88 centimeter. 88 comes, so we 88 now. 88 it is given in the question 88 centimeter. 88 centimeter is what? Lesser than 61. And then it is given as 88 centimeter and the customer will reject the part if it is either reject. If it is less than 88 means it is beyond this limit. So population mean will not be in the 88. It is more than 89.61. So naturally the customer will reject. The other one is 92. 92 centimeter. Okay, is greater than 90.39. So 88 will come outside this. Okay, and 92 also will come outside this. So this is outside, no? Is lesser than 88 means somewhere here. I can draw the line and straighten and show you. This is 89.61 and this is 90.39. This 3 90.39. 90.39. So lesser than 89, 88 will somewhere it will come. Okay, and 92 will be somewhere, it will come here. So lesser than this and greater than this. So 95%, what does the 95% confidence interval for the true mean length of all components produce ensure acceptance of the acceptance by the consumer. The customer will reject the part if it is either lesser than 88 or more than 92, right? So our final answer is yes. This implies that probability that the true value of the population mean length of the components will fall in this interval. Hence, we conclude that 95% confidence interval ensures acceptance of the component by the. Have we written this? Yeah, we'll write it down. So we have to conclude finally. What is our conclusion? This implies what implies? We'll see. The probability that the true value of the population mean length of the components will fall. This is will. Okay. Will fall. Okay. This implies what it implies, the probability that the true value of the population mean length of the components will fall in this interval, that is 89.61 comma 90.39. It is less than or equal to, now it is closed interval. Okay, at 95%. Okay, hence we conclude that 99%, 95 now, %, confidence interval ensures acceptance of the component by the consumer. This is what we have to conclude, right? So we go to the next example. What is the next example? We'll read the question. This is the question. A sample of 100 meters. Okay. A sample of 100 measurements at a breaking strength of cotton thread gave a mean of 7.4 and standard deviation is 1.2 grams. Find the 95% confidence limits for the mean breaking strength of cotton thread. What is given here is a sample of 100 measurements. So sample size is 100 measurements. At the breaking strength of cotton thread gave a mean. Mean of the sample is 7.4 and standard deviation is 1.2. Here everything is given about the sample, right? Mean of the sample and standard deviation of the sample. Note that. And they are asking 95% confidence limits. For the we are supposed to find 95% confidence limits for the mean breaking strength of the cotton thread. That is the question asked.